Welcome to Summarize Science. We all know AI can be incredibly smart, but what happens when it's confidently wrong? In fields like medicine or finance, a single wrong answer from an AI can be disastrous. This is a huge problem called hallucination, and it's a major roadblock to trusting AI with important tasks. Researchers behind a new paper decided to put today's top AI models to the test. They gave them difficult problems and explicitly warned them, you will be heavily penalized for wrong answers. But guess what happened? The models almost completely ignored the warnings, choosing to guess confidently rather than simply say, I don't know. This shows that the way we currently train AI, which rewards any answer over no answer, is fundamentally flawed for high-stakes situations. So, they proposed a simple but powerful fix called reinforced hesitation. Instead of the usual right or wrong training, they introduced a third option, abstaining. In this new system, a correct answer gets a positive reward, saying I don't know gets 0, and a wrong answer gets a negative penalty. This small change teaches the AI that sometimes silence is the smartest answer, especially when the cost of being wrong is high. By adjusting the size of the penalty, they could create a whole family of specialized AI models. Models trained with low penalties were aggressive and answered almost everything, while those trained with high penalties became extremely cautious conservatives. This created what's called a Pareto frontier, showing that there's no single best model, but rather different models optimized for different levels of risk. But here's where it gets really clever. They turned the I don't know response from a failure into a useful signal. They developed a technique called cascading. First, you ask the most cautious, high-penalty model. If it says, I don't know, the question is automatically passed to a slightly more risk-tolerant model, and so on. This triage system was incredibly efficient, achieving nearly 90% accuracy while using way less computing power than other methods. Another method, self-cascading, involves simply asking the same model the question again if it abstains. Because of the slight randomness in how AIs generate answers, a second or third try might lead it down a more confident path to the right solution. This simple trick boosted one model's accuracy from 77% all the way to over 92%. So let's recap the key breakthroughs here. First, current AI models are bad at admitting when they're uncertain because they're trained for accuracy above all else. Second, a simple training method that penalizes wrong answers can create AIs that are much more honest about their limits. And finally, that honesty can be used to build smarter, more efficient systems that delegate tasks based on confidence. This work is a huge step towards building AI we can actually trust. Imagine a future where a medical AI doesn't just guess a diagnosis, but knows when to say, I need to consult a specialist, making it a much safer partner for doctors and patients.